Modern construction treats wood rot as an unavoidable enemy, something to be managed with pressure-treated lumber, chemical preservatives, sealants, and coatings that promise protection but rarely last more than a few decades. Yet long before chemistry labs and industrial formulas existed, medieval builders had already solved the problem, not partially, not temporarily, they solved it for centuries. Across Europe, wooden beams from the Middle Ages still hold roofs aloft, support stone cathedrals, and survive in damp climates that destroy modern lumber in a fraction of the time. These structures weren't preserved by accident. They were built using a systematic understanding of wood, moisture, and decay that modern builders largely abandoned. Medieval craftsmen didn't know about fungi, microbes, or cellulose degradation, but they understood the effects. They observed that wood rotted faster when cut at certain times of year, when sealed too early, or when buried improperly. Over generations, they refined a process that attacked rot at every stage of a tree's life cycle. To them, wood was not dead material. It was something that needed to be transitioned carefully from living tree to structural beam. Medieval builders harvested timber almost exclusively in late winter. This wasn't superstition, it was practical biology. During winter dormancy, trees contain far less sap and sugar, meaning there's less food for rot-causing organisms. Modern forestry confirms that winter-felled timber absorbs less moisture, shrinks less as it dries, resists fungal colonization, and stays structurally stable longer. Industrial lumber today is cut year-round to meet demand. Medieval builders refused to compromise on timing. Once felled, medieval timber was never rushed into construction. Logs were stacked off the ground, protected from rain, and exposed to steady airflow, sometimes for years. This slow air seasoning allowed moisture to leave the wood naturally without cracking fibers or trapping water inside. Modern kiln drying removes moisture quickly but creates internal stresses that invite future rot and warping. Surviving medieval beams show tighter grain structure and fewer microfractures than modern lumber, one of the reasons they resist decay so effectively. One of the most misunderstood medieval practices was surface charring. Builders lightly scorched beams with flame or hot iron before sealing them. This step alone dramatically reduced rot. Charring destroys surface fungi and insect eggs, creates a carbon layer that repels water, hardens the wood's outer cells, and slows ultraviolet degradation. This technique still exists today in Japanese shosugi-ban, but medieval Europeans used it centuries earlier for beams, posts, and foundations, especially where wood met stone or soil. Instead of synthetic preservatives, medieval builders relied on natural substances with powerful antifungal properties. Common treatments included linseed oil, which polymerizes inside wood fibers, pine resin and tar, both highly water-repellent, animal fats which sealed pores and maintained flexibility, and tannin extracts from oak bark or galls, which are actually toxic to decay organisms. These substances were heated and applied while hot, allowing them to penetrate deep into the wood. As they cooled, they hardened into a flexible, water-resistant barrier from the inside out. Modern coatings sit on the surface, while medieval treatments became part of the wood itself. Medieval builders didn't rely on treatment alone. Their designs, minimized moisture exposure in the first place. They built with wide roof overhangs to keep rain-off beams, raised wooden structures away from soil-stone foundations that isolated wood from ground moisture, and joinery that allowed wood to expand and contract without cracking. Cracks are where rot begins. Medieval joinery reduced cracking by allowing movement rather than resisting it. The results speak for themselves. Norwegian stave churches from the 1100s still stand. English timber frame houses from the 1400s remain solid. Cathedral roof beams older than modern nations show minimal decay. Meanwhile, modern pressure-treated lumber often fails within 30 to 50 years outdoors. The medieval solution to rot wasn't lost because it failed, it was lost because it was slow. Industrialization demanded speed, uniformity, and mass production. Kiln drying, chemical preservatives, and fast framing replaced patient craftsmanship. The knowledge lived in guilds, not textbooks. When guild traditions collapsed, so did centuries of material wisdom. Today, sustainable builders and historians are rediscovering medieval methods, and honestly, the results are striking. Structures last longer, require fewer chemicals, and age more gracefully. Medieval builders didn't fight rot with chemistry. They designed it out of the system entirely. Long before modern science gave rot a name, medieval craftsmen had already beaten it, and their buildings are still standing to prove it.